Hi everyone! Today we're gonna look at a simple DRAM tester which I made recently. It needs, well, a DRAM chip obviously and an 8-bit microcontroller. I have microchip PIC16 family here. It has an 8-bit RISC core and a good deal of peripherals, but we need only basic digital I/O ports. It has an external high-speed 20 MHz clocking. Well, that's because we need to comply with a DRAM datasheet and use the recommended timings for row and column address select signals. Some DRAMs will tolerate much slower signal, but our goal here is not to exercise the tolerances, but to apply pulses within the specs and expect for the memory chip to act accordingly. Here we can see our RAS and CAS signals in the oscilloscope. Just do a single swipe to freeze them, and now we join them together to make sure they're exactly the same as our datasheet recommends them to be. Yeah, that's it. Yeah, the same. Well, being a dead simple one, this tester doesn't have any particular human readable output. Instead, it produces a short pulses that could be observed on the oscilloscope, which are repeating the readouts from the RAM chip. The tester just scans through all the rows and columns in an endless loop, trying to write and then read back ones and zeros one by one. If there would be any difference, for instance we have written 1 but readout is 0, or vice versa, it will just stop the cycle and hold the output in a state that we didn't expect to be there. Well, basically that means a flat line on the oscilloscope screen. So we just introduce an error by shortly touching of a ground wire to the data output of the memory. Yeah. And let's now observe the flat line of the screen, and everything stops, and this state indicates failure. This stops, the scanning has been stopped, and well, program should be restarted to move further. As the program consists literally of a few lines of an assembly code, anyone could do anything to indicate a human readable error. For example, a blinking or steadily lit LED or something like this, with no need to have an oscilloscope hooked up to the board. The MCU has plenty of program memory space. Even for a serial port activity can be implemented by simple bit banging in our case. Yeah, and here we can see an output of our DRAM chip data line. It has been hooked. The probe has been hooked to it, and on the oscilloscope screen it looks like this. Well, let's just sink into, yeah, and this is our zeros and ones that we're reading from the memory. That was nice peaks are visible here. Well, also one important thing, you should have your filter capacitor installed over the power lines of every chip, especially the DRAM, to level out the voltage surges introduced by the chip itself. Your 0.5 microfarad should be installed on the shortest possible path, like this here. Well, thank you for watching, hope you enjoyed this video, and see you again next time.